Good morning, everybody. My name is Muzli. I work for BMKG, Agency for Meteorology, Climatology, and Geophysics of Indonesia. So today, I'm going to talk about the microzonation of earthquake hazard in Banjar City, West Java, Indonesia, in collaboration with other authors, as you can see here. So the outlines of my talk. First of all, I'm going to start with the introduction of the microzonation of earthquake hazards. And then I will show you the Banjar City, the location of Banjar City in Java Island. And then I'm going to talk about the method of the microzonation that we are using here, 8/V and MASW. After that, I'm going to show you the results and close with the summary. Let me show you this Mexico earthquake in 1985. I think many people are familiar with these figures and this phenomenon, especially. If you still remember, in 1985, there was an earthquake in Mexico with the magnitude 8.1. Interestingly, that the earthquake was relatively far away from Mexico City, about 400 kilometers, but the Mexico City was destroyed significantly because of the earthquake. This is because the city located on the relatively very thick sediment. And we know that the seismic wave can be amplified because of the soft sediment. So based on this historical phenomenon and also other cases, actually, what we have to do, to mitigate the earthquake disaster, we have to understand correctly the location of the building or infrastructure or the city. So what we can do is to map the zonation of the seismic hazard or earthquake hazard, what we normally call the microzonations of earthquakes, microzonation of earthquake hazard. So we map the zonation of the seismic hazard in the micro scale or in the relatively small scale of the region. So these are here some projects what we have done from BMKG, especially from the research and development centers. So we have conducted several microzonation mapping, mostly in Java region, but one of them we also have conducted in Padang in 2011. So I believe that other institution has also conducted similar project of the microzonation mapping in other location in Indonesia. So I would say this microzonation map here should be useful for the engineering in relation to the building construction following the building code. In this year, we have the opportunity to conduct the measurement of to make the microzonation map in Banjar City. So as you can see on the slide, we show you the location of the city. Here, the city located in Java, uh, in the boundary between the West Java and Central Java. This relatively small city connected between Bandung, a big city in Central Java, in West Java here, to the southern part of Central Java, Pangandaran and other cities here. So the size of the Banjar City about 40 kilometers from east to the west and 12 kilometers from north to the south. So relatively small city. What we have done for the microzonation map in Banjar City, we have conducted two experiments, two measurements. The ambient noise measurement, we record the ambient noise 30 minutes at 342 sites. We use this ambient noise to calculate the 8/V ratio, or 8 horizontal to vertical spectral ratio, to identify the site classification. Moreover, from this 8/V, we obtain the peak or the dominant frequency, and then can be interpreted as what is the thickness of the sediment. So we use the short period sensors and conduct the measurement at 342 sites. Here is the examples of successful application of 8/V method. We show you the reference here from Parolai et al. An example. They measure the 8/V. I show you some location here, which has been done at a well-known geological condition, with the light gray here, the sediment, and the the dark gray here is a relatively harder rock, or the rock. So here is the sediment relatively thicker compared to this location here, with the scale here more or less 200 meters. And measurement of the 8/V at these three locations, showing the peak frequency dominant for the thicker sediment at lower frequency, and on the other hand, for the thin sediment or the rock, showing the peak frequency and higher frequencies. So this is a relatively simple method, but can be used to interpret the site classification very well. And we have done this measurement at the 342 sites. As you can see, the locations here, the distance between one point to others, more or less about 1.5 kilometers, entire Banjar City. Another method, we also have conducted MASW, multi-channel analysis of surface wave. So what we have done here, we installed 24 geophone, and then we give the active source, and it is recorded by 24 geophones. As you can see, the surface wave propagate here with this slope. The higher the slope here indicate the softer the sediment. Oppositely, the slower the propagation, showing the smaller the slope, indicate the harder the rock. or the location we conduct the experiment, because the surface wave can propagate quickly, indicate the material or the location where we conduct the experiment is relatively harder rock. We conduct the MASW measurement at 31 sites, as you can see on the map here. And now I'm going to show you the results. So for the measurement of VS30, we obtain the contour of the VS30, or the shear wave velocity down to the average shear wave velocity down to 30 meters, as you can see on the left here. And on the other hand, actually, we can also measure the VS30 based on the topography slope, as it has been done by USGS. So if you want to have the empirical one, you can download it from USGS based on the topography slope. And you can see here the comparison between the measurement and the empirical. They are not too different. I mean, agree each other. However, of course, we believe that the measurement has to be realistic, much more realistic compared to the empirical one. Unfortunately, for the H over V, we haven't finished processing the data, so we cannot show you at this time here. Let me make the summary of this short talk. So the summary of what we have studied for the microzonation, Banjar City. The eastern part of Banjar City has a relatively thicker sediment compared to the western, and in general, the result of VS30 measurement in our study comparable with the empirical VS30 based on the topography slope. Thank you.